Then I'll share my screen.
iPhone all the way.
Oh, did the poll pop up?
Yeah, I see it.
I wonder why. It was in my previous class. I was just it was an architecture class, and we were talking about roughly, well, who uses Android versus who uses iPhone, and as expected, we had exactly 50% each. But we were talking about some of the battery decisions made and that kind of stuff. All right. All right, this is us, right? 250? And everybody can see the slides and everything? All right, so, well, let's get trucking. So same as last semester, but if you aren't on it, the Slack channel, go to cuwcs.slack.com. Make sure you create an account with your cuw.edu email address and join the 250 channel. So I'll put announcements and stuff like that up there on Slack, and it'll also be beneficial for you when you're working on homework assignments to be able to ask questions of, you have a bug or something like that, and whether it's me or somebody else in class who responds first, but it's an easy way to get your questions out to everybody. The tool we're going to be using in here initially is a tool called Eclipse. So if you go to eclipse.org, and I'll actually go ahead and do this, so I'll get the latest version too. So you go to, did I hit that? There we go. So if you go to eclipse.org and then you click download, and it should have the Eclipse IDE for 2020. You can do that, or you can go to download packages, and you specifically want the Eclipse IDE for Java developers. The other one is like their downloader, so I'll actually do the normal downloader to see what it looks like. So I'll click on that. So this will, I'll put my downloads here. Should grab it pretty quick here on campus. So you'll download it for your particular platform. I'm going to double click on the Eclipse installer. And ultimately, we're going to pick the Eclipse for IDE for Java developers. It's going to ask me where do I want to install it, blah, blah, blah. So just use the defaults. It's asking where the Java 11 virtual machine is. It already found mine. But if you're on a machine where it can't find it, most of you or many of you might already have it installed. You can go to java.sun.com, which is going to redirect to an Oracle page.
Do we want the one from Canada?
Of course, you want the one from Canada.
Okay, just making sure.
Let's see. So once you come to oracle.com, go to under top downloads, go to Java SE, and you could actually just go over here to newest downloads. If you go to the Java SE 11.0, this is the latest release version. That's their stable version. You can grab the newest, latest, greatest, it doesn't matter. But get the SE 11.0, download this and install it. And once you've done that, if you launch the Eclipse installer again, it'll find it right here. So if it can't, browse to wherever it installed on your computer. So it finds it because Eclipse is written in Java. So it needs the, well, aspects of it are written in Java, but whatever. It needs the Java development kit in order for you to do your pass through for writing your Java code and running it from within the tool. So once both of these things are filled in, click install. And it's probably going to do some downloading and things like that to grab the correct package for the Eclipse IDE for Java.
I think you might only be sharing a specific screen, or my feed is frozen, but I'm not sure.
Or like sharing everything?
Yeah, like I don't want to say.
I still see the Eclipse page only, Eclipse Foundation website. That, yeah.
Do you see it now?
I
Eclipse
just have a
installed?
black screen right now.
Me too.
Yeah, not the black screen. There you go. Now we see it.
Yeah.
All right, so it did all this, whatever, click launch. And this will, so it looks like the latest greatest is the Eclipse IDE 2020. It'll ask you when you're, where you want your workspace. The default is like in your home directory. I don't care where you put it. I'm going to go ahead and say use this as the default and do not ask again. You can do that if you want. This is where it'll put your Java projects. Then click launch. This is noticing I had an old workspace. They want to know if I want to upgrade it to make it work with the current one. That's fine. So I'll just hit continue. Since I had a previous version on here. Okay, and there's the tool we'll be using. We'll maybe mess with it a little bit today, but that's the process that you'll want to go through to get a working, the tool that we'll use initially for writing Java code in here. Okay, so back to the slides. All right, so that's Eclipse, and I'll just say, if you need the Java development kit, actually, heck, I'll just give you the direct link. There's that. And I already have the slides shared, and their link should be up on Blackboard for these slides. All right, so questions about Eclipse and the Java development kit?
On the installer it says Eclipse IDE for Java developers or the enterprise. Which one do I pick?
The one for Java developers, the normal one.
Okay.
All right, so the same thing as last semester. I already sent out a note and many of you already replied back. Every class will be face-to-face as well as online because we have obviously the COVID capacity in the classroom. So what I asked you to do, and I'll ask you again now in case you haven't already done it, is if you have a strong preference to come to class face-to-face, message me and let me know, and what I'll do is unless we have the whole class who has that strong preference, I'll effectively reserve a seat for you so you can come to class face to face every class. And those of you who are fine with being online and don't think that impacts your learning style or whatever, can just be online or take advantage of one of the other seats, with the ultimate preference being that or the ultimate goal being that if somebody wants to be face-to-face, I want them to be face-to-face every class as opposed to having to switch back and forth. If you don't really care, you're certainly welcome to come face-to-face, but I'll give you an idea how many available seats we have. As of right now, it looks like we should be fine for open seats. So I would imagine that if you for the next class, so Wednesday at 11:05, if you wanted to come face to face, just show up, and I doubt very much we'll have a capacity problem. If we do, we'll figure it out then, and then we'll come up with another plan. But based on what I've seen so far, it looks like a good number of you prefer online. The only thing I would challenge you with is make sure that you're choosing to do it online because you think that you legitimately are fine with it and it doesn't impact your learning style. If you really think that being online negatively impacts your learning style, I encourage you to just get up earlier and get to get to the actual classroom, so that you can be successful in the class. I know how convenient it can be to just roll over and pop open the laptop and you're good to go. But if that's just not compatible with how you learn, I'd rather you be successful. And worst case, if we have to find a bigger classroom or do something else, we'll just do it. All right. So, like I said, if you feel strongly about coming to class face-to-face, definitely show up to class face-to-face on Wednesday. If you prefer to be face-to-face, show up as well. And then we'll just figure it out from there. Sound good? But every class will be on face-to-face as well as on Zoom. And I also record every class, so you'll be able to go back and refer to them and all that jazz. All right, questions about that? All right. Assessments. So categories, we're going to have Bible homework. The Bible homework is going to be a little bit different this semester. In the past, I've done like assignments every single week, which I don't necessarily have a problem with, but one thing that I run into is, students forget about it for some week, it just falls off their radar or whatever. So what I'm actually doing this semester is there's going to be 3 kind of larger Bible homeworks. I'm going to put them all up right away. They'll be up today sometime. And they're all 3 of them are due by the end of the semester. Okay. So actually, I think there'll be 3. There might be 4, but whatever. There'll be 2. There'll be 3 or 4 Bible homework assignments. You just need to make sure you complete them by the end of the semester. They are reading entire books from the Bible and then responding similar to what you did last semester. So I would encourage you to schedule kind of a weekly reading type thing, so it's not very much of a time commitment for you across a week in, week out basis. But however you decide is the best way for you to accomplish it is fine. It's due by the end of finals week. All right. Questions about that for the Bible homework? All right, normal assignments, 50% of your grade. There'll be, mostly programming assignments. There might be some other forms. There could also be quizzes in class. If I do a quiz in class, it'll be on Blackboard. So you'll either do it during class on Blackboard face-to-face, digitally, or if you're attending class online, you would do it on Blackboard online during class. But those quizzes will be generally, if I do them, they might be like the first 10 minutes of class or something like that, where you would need to be present in class to do it. It won't be something that's necessarily take home. Midterm and final, same as last semester. If you do better on the final exam than you did on the midterm, I'll replace your midterm exam score with your final exam score, not the other way around. So remember, homework is like practice for the big game. So I do grade homework relatively easily. I encourage you to work in groups and collaborate on the homework, so you ultimately learn the best you can, whether you're learning from me, you're learning from your classmates, a little bit of both. Sometimes you just need somebody else to explain something to you in a different way and it makes sense. So I strongly encourage you to get into study groups or whatever for completing the homework assignments, so that they prepare you for the exams. All right. The goal is not just to get the homework done. You're probably going to get a good grade in the homework, whether you learned anything from it or not. But I'm going to find out on the exams how much you've actually learned. All right. Make sense? All right, questions about the grading or anything?
Do you ever offer extra credit or anything like that?
Every now and then, yes, but historically what I've done is when we have our tech talks and stuff like that on campus, I've done extra credit in the past. I would say that my current MO is I shouldn't have to bribe you to do things that help you. So I, I mean, our tech talks have translated into internships for a lot of students. So if you want to waste your time on and not show up to them, that's fine. So I would say that there's always a chance at extra credit, but I probably do it significantly less often than I used to. I mean, you're all adults, and I think when you visited campus, I kind of mentioned that 90% of what you're going to learn, you'll probably learn outside the classroom. So you have to take on those projects, those extracurriculars, do the hackathon things, all that stuff. I shouldn't have to bribe you to go and do them. You're only hurting yourself if you're not doing them. And I think if you go back and look at all the students who get the top paying jobs after they graduate, they're all students who went to the tech talks. They went to all the hackathons, things like that. So, I realize everybody has a social life, but you decide what's important to you and that kind of stuff. So I won't say absolutely not, but you won't have a huge prevalence of extra credit type things. All right. Other questions about grading? All right. No official book for the class. We'll be using the Java documentation. For a lot of stuff, we'll also be using the Android documentation. We'll spend about the first half of the class doing core Java stuff, and then the second half we'll be doing Android development, well, Java development in the context of Android development. So by the time you're done with the class, you'll be able to write simple Android applications, but more importantly, you'll be able to read the documentation and leverage things that maybe you've never used before, but now you'll have the background to go and use those things relatively quickly, even though we maybe didn't cover it in class. All right, so no official book you have to buy. Self-assessment, so same as last year. Every single time you turn in a homework assignment, this wouldn't be required for the Bible homework, but any normal homework assignment, turn in the self-assessment. I want to know about your experience in doing this. Programming specifically is one of those things where you might spend 5 or 6 hours on an assignment and have nothing to show for it. Well, it's hard for me to give you a grade when you don't turn in any stuff. So I need to get your, tell me about your experience. What works, what doesn't work? What did you try? Also, as you might imagine, grading that many programming assignments can be a little bit time consuming. So if you give me an idea of where you went wrong, that helps me zero in on your code so I can give you some feedback as to why that was a problem. All right, so make sure you fill out the self-assessment for every assignment. Depends on my mood, but I have been known to deduct points if you don't include the self-assessment. And the number of points that get deducted might be completely arbitrary, again, based on my mood. So, so I guess that if I were you, I would just turn in the self-assessment, so you don't have to worry about that side of things. All right, questions about grading and all that stuff with the class? Okay. Like I said, I mean, officially it's a face-to-face class. I encourage you to come face-to-face if it's important to you. If you prefer to be online, that's fine. Every class will be delivered that way. I will randomly take attendance to be able to mark whether you're showing up to class or whether you're not. And I'll use that information when deciding to give you the benefit of the doubt, or whatever. If you have a borderline grade, if you're somebody who doesn't show up to class, you don't turn in your homework assignment, don't come in at the end of the semester asking for an extension to turn in, 15 missing homework assignments because you chose not to do them during the semester. You won't do well in the class anyways, and many of you kind of saw that last semester. Last semester, if you didn't do well in the class, really ask yourself why. I would say 9 times out of 10, students who struggle with programming try to do too much of it on their own. They don't get involved in a study group or, any sort of collaboration with classmates. So they're not being held accountable for doing the work on their own, and they're not getting successful. They're not seeing more successful solutions as the semester goes on. So if you're not getting that practice, you're not going to get better at it. You're not going to learn the stuff. I get paid either way. So at the end of the day, you're paying all this money for college. You might as well put in the effort to learn the material. But again, a reminder, just like last semester we talked about, Computer programming is not computer science. It's the tool that we use to solve a lot of problems. And it's kind of like a sport. So you got to put those reps in. You know, you can't just cram it the night before and expect to walk in on the exam and perform reasonably. All right. So maybe reflect yourself anyways, but reflect on your grade from last semester and decide, would I have done better had I worked in a study group to work on this homework with classmates instead of trying to do it myself and rarely be successful. So even though I solved it at the beginning of next class and you saw the answer, even if you understood the answer, you know, you didn't put in the practice, you didn't put in the reps because you kind of hit a wall early on in trying to complete the assignments. All right, so questions, comments, concerns, bribes before we jump back into a little bit of review and then start converting over to Java mentality. Okay. Oh, hold on. Somebody was a hashtag called out. All right. Let's see, what am I doing? Okay, so we're going to do a little bit of a review, but I'll kind of go through this pretty quickly. If you remember back from last semester, one of the things I kind of mentioned is that computer programming is, well, the language does not matter. Last semester, we were looking at Python. This semester, we're going to be looking at Java. Next semester in 300, we'll be looking at C++. In software engineering next semester, I'm pretty sure Dr. Locklear uses .NET and C# in there. If you take the 450 class with me, you'll be using C. If you take the 470 class with me, you'll be using Scheme. So you're going to get exposed to a lot of different programming languages. And I really want to reemphasize this idea that the language does not matter. Okay. Programming is the skill set that you're gaining competency in. We're switching up languages to give you some industry experience with languages that you want to be able to put on your resume and say, hey, I know how to use these, because these are all industry standard languages that are, you'll see as skills required for getting jobs and things like that. But on top of that, as proof that you can pick up a language very quickly once you know how to program. All right. So if you remember back from last semester, we talked about how do human beings solve problems? Well, we use our memory, we ask a lot of questions, and we have repetition. And we talked about what's the job of a programming language. The job of a programming language is to allow a person to tell a computer what to do, right? And ultimately, because we're lazy and we don't have a lot of respect for computers, we want computers to come 99.9% of the way to the way we already solve problems. We don't want to have to talk to a computer in zeros and ones. We want the computer to, we want the programming language itself to allow us to express solutions to problems in ways that are similar to how we already solve problems. All right, so 100% of programming languages will have facilities for memory, usually through variables, asking questions through conditionals like if statements, and then repetition through things like functions and loops and methods, which are synonyms for functions. So those types of things. So if you sit down in front of a brand new language you've never seen before and you say, well, how do I define a variable? How do I ask a question? And how do I write loops and functions? You can solve a large classification of problem with that brand new language pretty quickly. And all you're really doing is learning the little syntax caveats. That's different between the language, but still the programming mindset is the same. All right, that makes some sense? Okay, so we talked about last time, you know, that we had two different kinds of programming, two different types of programming languages. We had all those different slides. So we had loosely typed versus strongly typed, and we also had interpreted versus compiled. Remind me, what's the difference between a loosely typed and a strongly typed programming language? You're allowed to unmute yourself.
So loosely type is like there's more than one way to do a problem, where strongly typed you have to do very specific wording and stuff like that. Like now, there are loosely typed is there are multiple commands to do one problem, where strongly typed is there are specific commands.
Let's try again. Anybody else?
I think that loosely typed had something to do with variables where you can rename the variable or something like that. And then strongly typed, once you set a variable, it's kind of like set in stone or something like that. I forgot the exact wording.
Okay, well, we're getting closer, but yeah, this is still not good.
Okay.
Anybody else want to take a stab at it?
Is it when
Oh.
you define a variable, you have to say what kind it is?
Yeah.
Strongly typed and loosely typed. You
Loosely
don't.
typed was the strongly typed. Loosely typed does not require us to define the kind of value a variable will hold. Strongly typed does require us to define the kind of value a variable will hold. Okay, what about interpreted versus compiled?
I think compiled means that we basically have to do a translation before we run the whole thing. And so basically that we have to compile it first. And I guess interpreted, we don't necessarily have to compile it first.
Oh, you're back. Are you in the States?
Yes, I'm back.
Are you in the States?
I'm in the States, yeah.
Nice. Weren't you trying to be like a professional soccer or
Handball, yeah, because of COVID, it shut pretty much everything down in Germany. So I just decided I'll follow education.
Okay, well that's probably good.
Yeah.
But I don't know, maybe were you really good at handball?
Actually, yeah, but it's all right.
Yes, I don't understand the sport, so maybe sometime you can give me a tutorial.
It's pretty much soccer, just with your hands.
Soccer with your hands.
Pretty much it.
Okay. All right, so interpreted versus compiled. Interpreted languages like Python. So these languages interpreted like Python. Code is converted into low-level code at runtime. Compiled, like Java, code is converted into low-level prior to runtime. So we might say this is relatively fast, and we might say this guy is relatively slow, something like that. All right, that makes some sense. All right, so from a loosely typed versus strongly typed world, in Python, we would say something like name equals Mike. In Java, we would say string name equals Mike. This is the kind of value that this variable name will be holding. And then we can actually put that kind of value in it. In Python, we're allowed to do things like name is equal to 17 if we wanted to. We can originally put Mike in there, and then we can change the entire kind of value that it holds to a different type. So in this case, the same variable is holding a string, and then it's holding a number. In Java, we can't do that. If I set it like that, and I say name is equal to 17, Java will scream at me saying, name is a variable built for holding strings. 17 is not a legal string. Make sense? So that's the difference between a loosely typed and a strongly typed language. Now, the question is can you make an argument on why a loosely typed language? Well, here, let me, instead of preheating you, which is better and why? Loosely typed versus strongly typed, which is better and why? I think you can make a reasonable argument either direction, but I'm interested in what those arguments are.
I feel like personally for learning purposes in the beginning, it might be better to use a loosely typed language because it allows us to, basically do what we want to do and get some experience. But I'm not entirely sure why one would be better than the other. I feel like I'm trying to name, what would be differences between the two, like why it's important, and I'm not sure.
When you're picking your variable names, so you're writing your program, you're picking a variable name. How do you name your variable? What consideration do you take when you're coming up with the name you should use for your variable?
Whatever it's being used for. So like if I was gonna, making a person, I would probably make the variable that person's name or something. I don't know, something like that.
Okay. So yeah, if you were storing somebody's name, you might name the variable name. If you were storing their age, you might name the variable age. So you name the variable something that's kind of related to the kind of value it's going to hold so that you can remember it later on, right? We typically wouldn't just store it in generic variables. Like we wouldn't say A equals Mike and B equals 17 and then remember 600 lines later that A holds a person's name and B holds a person's age. We would name the variables appropriately based on the kind of value it was holding, right? So with that in mind, the question is, would this type of thing here ever really make sense? Just because you can do it, does it actually ever make sense? Would it make sense to put the number 17 inside of a variable named name?
I guess not.
Yeah, probably not, right? You probably would not switch up the types very often. I mean, I suppose we could probably sit here and, in a few minutes, maybe come up with some weird example where, hey, yeah, I guess that sort of kind of can make sense. But generally speaking, just at a glance, we would say, when I first create a variable, I pretty much know what kind of value I'm going to put in that variable because, names are strings, ages are numbers, things like that. So with that in mind, you don't necessarily have have any real advantage. In fact, you might even say that loosely typed languages like Python maybe allow you to be a little sloppy, right? They allow you to kind of reuse a variable for different kinds of values, which maybe allows you to not be as particular about how you name your variables. Go ahead.
Couldn't it be that it's like, maybe more work though to have to name your variables and stuff? If you're going to be using it as a string anyways, why have to like label it? What's the point of labeling them or like clarifying what they are?
Well, what do you mean? You like
Okay,
why call it name instead of A?
Well, no, like, okay, say if you're gonna use the variable name and then you're gonna make it a string that says Mike, right? What's the point of having to label it as a string, like saying that name is a string? Like, why do you have to label the variable type? I don't see the point in it necessarily. Isn't that just extra work? That's my question.
Yeah. So it's actually a good question. So it actually has to do with the implementation of compiled languages. If you look at a even newer language like Swift, Swift does not make you label. It is a strongly typed language. It doesn't make you label it. Instead, what it does is the first time you put a value in it, that's the kind it becomes. So if you put a string in it initially, it gets locked in as a string type. Now, having said that, to answer your question, kind of a modern trend in programming languages seems to be, and we're going to see plenty of examples of this with Java, but it seems to be a move towards, having the programmer use less keystrokes, something like that. And, you might say from an efficiency perspective, that makes some sense, but there's also a point where it's overkill. The joke I make, I don't know if I said it in the class last semester or not, but the Swift programming language allows you to use emojis as variable names, which seems ridiculous to me. It just seems completely ridiculous to me. At some point, you're just crossing a line when you don't even use a normal language to. And then the funny thing is, we kind of like are taking a step back. That's like using hieroglyphics from Egypt. But the point is I think from a good programming practice perspective, if you sit down to create a variable, I think that by forcing yourself to write the type of value that variable is built to hold is good programming practice, because it all makes you ask yourself, what is this variable for, and maybe forces you to name it something reasonable. So the idea would be that even though it costs you a few keystrokes, I think it's probably worth it from a kind of self-policing perspective. Okay. So at some point there's personal preference there, and certainly some languages are kind of, even strongly typed languages are removing that syntax, but I'm of the belief that removing all extraneous syntax isn't necessarily always better, because I think that there is knowledge to be learned in the writing of those things. Now, you might say after you've done it 1,000 times, it gets a little tedious. Why do I have to type that? So some tools like Eclipse and like Xcode, they have code snippets built into them where you can kind of put like a starting point, a template for like a for loop or something like that, and just click a button and it gives you a starting point for a for loop, as opposed to you having to write it from memory. But I like to start off for a long time writing it all from memory until you kind of almost get muscle memory from it for typing the stuff. So I think that putting the type in front of a variable is a worthwhile, or those involve worthwhile keystrokes as opposed to something that we want to save. Okay, so interpreted languages tend to be loosely typed languages. This kind of comes down to how they're implemented, whereas compiled languages tend to be strongly typed languages, because we need to convert it to low-level code prior to running it. A compiled language kind of needs to be notified of the kind of value a variable is built to hold, so that it can go and reserve enough memory to hold that prior to runtime. Okay, so they need to be a little bit more verbose for that. But punchline is, again, I come back to this idea that programming is the skill set that we're learning. We just happened to last semester work with a language, Python, that was an interpreted loosely typed language. This semester, we're going to be working with a language, Java, which is a compiled, strongly typed language. Now, the reality is Java is actually sort of kind of in the middle. It is compiled, but it actually is interpreted at runtime. Let's see if I have the slide that shows that. Well, I'll just write it in here, and then we can always, if I have it in here again, we'll just skip it the second time. Actually, I'm going to put it in text. So for Java, actually, I'm going to do this. So we start off with Java source code, which then gets compiled into Java bytecode, which then runs on the Java virtual machine. I'll just put that in a different slide. Runs on a Java virtual machine, which then interprets it to native assembly code, which ultimately runs on the CPU. All right, so that is how Java works. If we take a purely compiled language like C source code, it gets compiled into native assembly and then runs directly on the CPU. So what we're missing here is this conversion between this low-level language and this low-level language. Remind me, what's the difference between well, what are our three kinds of programming languages related to low-level, and what's the difference between them?
I think low level. Wait, is low level machine code?
Nope, those are two different things.
Okay, so well, I don't know the names of them, but I think there's like high, medium, and low, something like that. High level code is basically what we write today because it's easier. It's like shorthand basically. Then there's medium level code, which like is a little more involved. You'd have to type out more code in order to get the same thing done that you would with the high level code. And then there's low level code, which is even more. Is there even a medium? Is it just high, low,
no medium.
Okay. So that's high, low, and level. So we got high like English. Yep. Low level is a little bit closer to a little bit harder. You'd have to type up more things. And then machine language is basically all zeros and ones.
Okay. So ultimately, the CPU, if you remember us talking about the CPU last semester, we talked about it as kind of being this like collection of magic tricks, right? You know, first week of class last semester, I probably had you all wiggling your fingers, like, this isn't all that impressive when you move your thumb like this, and if you move your fingers like this, but if you put those movements together in a single thing, you can pick up, a coffee mug or a soda, a soda bottle, whatever it is. So human beings, we have all these little tiny abilities we know how to do, and only when we string them together in a certain order are we able to accomplish some tasks. So a low-level language requires us to talk about each of those tiny little moves that we have to do. It looks English-like, so it's not horribly cryptic for us to write, but it's much less convenient for us to be a computer programmer using that. You'll be looking at low-level code in the 325 class that most of you are probably taking this semester, the computer organization class, where you'll be talking directly to the CPU, and you'll realize pretty quickly that you will spend significantly more time writing less impressive code because of the amount of stuff you have to do. And if you want a reminder from last semester, I think we looked at Hello World Linux Assembly. We walked through this low-level program here. All right, so this is telling the CPU to do one thing at a time. This is a little magic trick. This is a little magic trick. This is a little magic trick. So we're moving this piece of information into this storage location. We're moving this piece of information into this storage location, this piece into this storage, this piece into this storage. Then we're interrupting and telling the operating system to take over. Now, this is actually still using a power tool. This isn't all written in assembly. Well, this is written in assembly, but it's utilizing system calls that are written in the operating system. So the syswrite function expects there to be three parameters. It expects there to know, where do you want me to write it? What do you want me to write? And how long is it? It needs three inputs in order for it to perform its magic trick. All right, so we're moving the magic trick we want to do into this location, and then the three parameters into the three other locations. And then when we ask the operating system to take over, which happens right here, it's going to check right here to find out what is it that you want to do. It says, oh, you want to do magic trick number 4, which is syswrite. Well, syswrite writes something to the system, writes something to the screen. Where am I writing it? Well, I'm writing it to the screen. That's standard output. That's a 1. What am I writing? This is our hello world. What's the length of it? However many characters are in hello world, 11, 12, with the space in there, 13, I guess. So It needs those 3 pieces of information. Then this guy right here that somebody else wrote does the magic of actually getting it on the screen. If we rolled back before we had these modern operating systems with these are called system calls. Once you take the 450 class with me and with system programming, we'll be working with these system calls directly, as well as writing our own system calls that interface with the operating system more directly. All right. But the punchline here is that this is an example of some assembly code. And then here's some more. This makes the program exit, where we say, this is what I want to do. I want to do sys exit, which requires no inputs. Actually, this is the exit code, so it does look an EBX for the exit code. But regardless, here's some example of low-level code. Certainly looks less friendly than like what you wrote in Python or what we'll write in Java this semester. So when we go back to this guy here, that low-level language here that has a one-to-one relationship with the CPU, each line of code equals exactly one magic trick that the CPU knows how to do. We're going to say that if we had to, a human being could write code that way, but we don't prefer it. We'd rather work with at a high level, having a one-to-many relationship where we just say print hello world, and then underneath the hood, when we compile it or we interpret it, it gets turned into all of this for us automatically. Okay, that's our preference as human beings. We like power tools. Okay. Certainly machine language, we're going to look cool for an hour, but then we'll go insane having to write zeros and ones all day long. All right. So these are the 3 kinds of languages that exist in the world of computers. And for us, well, we don't get to choose what a computer speaks. Computers are digital. They speak machine language, zeros and ones, ons and offs. So ultimately, our instructions need to get to that level. We can talk to the computer directly using their language, or we can use a power tool like Java or Python and let some other tools that somebody else wrote that we are capable of writing, but they would be difficult in and of themselves, to translate our code into that lower level stuff that ultimately can run on the CPU. Go ahead.
Could we write a programming language in high level, or would it need to be at low level?
Well, that's actually the perfect question. Yes, you can write a programming language at the high level. Those kind of programming languages are called interpreted languages. So somebody wrote the Python interpreter in like C language, and that guy was an interpreter for a new programming language called Python. Ultimately, under the hood, it's probably compiling it down into C code or something similar, or translating it into C code. But what it's doing is it's providing a friendlier syntax, presumably a friendlier syntax. Otherwise, why do you need a new language? For you, so you can write stuff using the Python syntax, but ultimately have it run on the computer that the interpreter was written for. Make sense? Writing a compiled language is significantly more complex. And that's why if you go out and look at the modern compiled languages, which are faster, for those situations where they need to be faster. But generally speaking, our languages don't need to be fast. But if you look at the modern trend in languages, we only have a handful, less than a handful of compiled languages. You have C, C++, Java, C#, Swift. Done. And or Objective-C, I guess, is in there. Swift is a newer version of that. And then really two of those languages are Mac only. So unless you're writing, if we're just living in reality, unless you're writing software for iPhone, which is worthwhile. I mean, there's a lot of money to be made specifically writing software for iPhone. Then you would work probably with Swift. But unless you're doing that, chances are your job will be working with Java or C#. That's the reality. Maybe C++, it is still founded if you get in kind of the game programming world or something like that. But I would say that 80% or more of industry jobs today are going, if they're dealing with a compiled language, will be in Java or C#, which are basically the same languages, and we'll talk about those. And maybe the rest is going to be C, well, maybe another 10% will be C++, and then the last 10% maybe C for embedded systems or something. But then if you're working in industry with loosely typed languages, Python is probably your poster boy for real programming, but using an interpreted language. You do have a lot of other interpreted languages, specifically in the web world. Okay, so questions, comments, concerns, bribes of anything we talked about today?
I'm sorry, I have one more question.
Sure.
So is like a for loop, like the function for loop or whatever, is that's the high level version of like multiple low level steps that talk to the CPU or something?
Correct. Multiple low level
Okay.
steps with typically with go-to statements that jump, but well, they're actually not, there used to be go-to statements. Now they're called jumps. It jumps back to a label. So if
Okay.
you were going through it, it would be do this, 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 and then based on the result of a jump, it would either go back to the beginning of that or keep going. So they actually look like loops even when you write it in the assembly, and you'll look at that in the 325 class.
Okay, thank you.
All right. I will get the Bible homework up today, but like I said, it's not due until the end of the semester, but I just want to get it up there. We are going to have tech talks this semester. I don't know the dates for them yet, but I'll give them to you as soon as I can. No homework for Wednesday, but I would say make sure that you get Eclipse installed and make sure that you're on the Slack channel in case we put any announcements up there. All right. I will see everybody on Wednesday.
Mr. Lippman,
Yep.
just a heads up, Friday, I'm going to be leaving. We have a hockey game